Welcome back. In this video, I am going to show you what is stress matrix and how you will represent this stress matrix on a three-dimensional state of stress. So we can define as a stress matrix is a 3 by 3 arrays of number representing the internal forces which are stress component and acting on the face of infinitesimally small cube within a material, defining the complete state of stress at a point. It captures both normal stress perpendicular to the face and shear stress parallel to the face and is a coordinate dependent representation of stress tensor transforming with change in the coordinate system. So you can see this is a stress matrix for a three-dimensional state of stress. So I will represent, let's say we take sigma xx or any value tau of yz. So this first subscript means that it is plane and the second subscript shows axis. Similarly here this shows plane and this shows axis. So with the help of this I will represent this stress matrix on this element, cubic element. So first sigma xx. So you can see that this is x direction and this is y-axis and z-axis. They make this plane as x plane. This is x plane. So you can see this sigma xx is in x plane in the direction of x. So I represent it like this. This will be sigma x x, and similarly on the other face it will be also like this, will be sigma x x. Now the second is tau of xy. So you can see that this plane is again x plane and tau shear force which is parallel, it will be in the direction of y. So it will be like this. So it will be shear stress will be this tau of xy. Similarly, on this x plane we have another which is tau of xz. So this is x plane. So we will have x plane in the direction of z. So it will be like this. So this shear force will be like this on this face. So this is tau of x in the direction of z. Similarly, now you can see that we have this state of stress. Each face will have three stresses. So again on the other face you will have the same, but we will see in a while. Now for this first one, tau of y in the direction of x. So you can see this is x-axis and this is z-axis, making this plane as y plane. So this will be your y plane. This one and this one both are y plane. And the first is tau of y in the direction of x. So I can write this like tau of this. I can write it over here, tau of y in the direction of x. Now the second is sigma yy. So sigma y, this is y plane and in the direction of y. So we have sigma yy like this. The third one is tau of yz, this one. So tau of y in the direction of z. So it will be like this. So tau of yz, this is this one. Okay, now what about this third one? So you can see this is tau of z. So this is x plane and this is y plane, making this and this both planes as z plane. So we can write it as z plane. So you can see the first one is tau of z in the direction of x. So it will be like this. I will choose another color. Let's say this magenta. So you can see this is tau of y. This one is tau of z in the direction of x. The second is tau of z in the direction of y. So this will be like this. Tau of z in the direction of y. And the last one is this one, which will be sigma zz, z plane in the direction of z. So what you can say that if this is upward, if you want to draw it below, so it will be like this one. This will be like this one. This will be tau of y in the direction of z. Similarly, this one will be like on the face, this will be tau of x in the direction of y. And this is how we have represented all these stresses. This shows x plane. This is stresses acting on x plane This is stresses on the y plane, and these are the stresses on z plane. And there are total 9 stresses that are acting and shown on this state of stress. I hope you have enjoyed this video. Thank you.